two integrals on the spot. The first one, the integral 1 over 1 plus sine square x. This one looks kind of familiar, isn't it? I think we did this before, huh? The second one, the integral 1 over parentheses sine x plus cosine x, and then raised to the second power. So now please pause the video and first try to recall how did we do that, and maybe the similar strategy will be helpful for this integral. Okay, so now let's look at this integral first. We have the integral. As we can see, this is the integral with sine x, right? Whenever we're dealing integrals with trig functions, we want to have sine x and cosine x because they can help each other out, right? They get along with each other. However, in this case, it's not so easy to produce a cosine x. And I cannot use any identity easily to simplify this expression, isn't it? So here is another thing that we can talk about. Besides cosine and sine x in an integral that they get along with each other, we also have tangent x and secant x, sometimes secant squared. But then tangent and secant, they also get along, they also can help each other out in an integral. So let's take this and change that into a tangent secant situation. And how can we do that? Well, here we have sine squared x already, and we know sine x over cosine x is tangent x, right? But then this is the second power. So let's divide this by cosine, and let's match the power. So cosine squared x. And we'll do the same right here and right there. So divide this by cosine squared x, and divide this by cosine squared x. And you know the deal, this is going to be the integral. On the top, we have secant squared x over, this is also secant squared x, and that's going to be tangent squared x dx. And now this is much more doable, because then we can use u is equal to just tangent x, and then the derivative of u is secant squared x, which we can cancel out the 1 on the top. And we can use trig identity for this one and then simplify it. Anyways, try to finish this on your own, or maybe watch the video that we have done in the past. I would just like to tell you guys the answer for this. The answer for this is 1 over square root of 2 inverse tangent, or the arctangent, and then inside we have the square root of 2 times the regular tangent x, and then we are done. So put plus c. This is it. And now let's take a look at this one. This is clearly an integral with sine x and cosine x. However, they don't help each other out in this case, isn't it? So now what? Well, let's use the same strategy. Let's take this integral and change that into a secant tangent situation. So now let's focus on here, right here. This is sine x. We know sine x over cosine x, that will give us tangent. So that's a good start. Let's look at this sine x and then divide this by cosine x. Okay? And keep in mind, we are dividing the cosine x in this parentheses. And let me do the same thing right here because they are both inside of parentheses. So divide just the cosine x. However, instead of the parentheses, we have to then raise to the second power. So technically, we are divide everything by cosine squared x. That means on the top here for this one, I will have to divide it by cosine squared x. Okay? Once again, this is cosine x, but then you have to raise that to a second power. And yeah, that's pretty much the same denominator, so that's why. And now let's take a look at what we'll get. This is the integral. On the top, we have secant squared x. Over the inside here, we have sine x over cosine x, that's tangent x. Plus cosine x over cosine x, that's 1. And then this is still in the parentheses, and then we have that raised to a second power. And of course, we still have the dx. And now what? As we can see, we can just let u equals to tangent x plus 1. And then we can finish this nicely, huh? So go ahead, u is equal to the inside tangent x plus 1. And we see right away du is equal to secant squared x dx. And then in this case, this is the integral. And let me just pair things up for you guys. This right here, secant squared x dx is the du. So let me put that down right here, and then we still have the over. The inside here is the u, and then that's raised to the second power. So let's put that down here. And to integrate this, let me just rewrite it. This is the integral of u to the negative 2 exponent, and then we have the du. And now what? We can just do pole rule backwards, right? So let's add 1 to this. Negative 2 plus 1 is negative 1, and then divided by negative 1, which is the same as multiplying by 1 over negative 1. Anyways, altogether, this is still negative 1. And then u to the negative 1 power, right? Times u to the negative 1 power. Are we done? No. At the end, this is negative. U is what? U is the tangent x plus 1. So let's put it down. Tangent x plus 1 raised to the negative 1 power. Of course, we can bring this down to a denominator, and we can write this as negative 1 over tangent x plus 1. And then we are so done. Plus c at the end. This is it.